And we will conclude with a subject about PIM to EIM, and it will be online too. So we will start with Nolwenn and Renaud about material roles in pavement design and its impact in low carbon strategies. Thank you.
Thank you, Sylvain. Good morning, everyone. Good morning online too. I'm Rodon Montaignac. I'm working at Oris, and Oris is a spin-off from Holcim, leader of material construction. And I'm with Nolwenn Lancien from Arcans. And we'll talk today about the material role in the pavement design. So how to integrate this material geolocation into the design process as early as we can to measure, anticipate, and decide about our pavement design without the impact, with the impact of environmental impact of this design. Just a quick background, we will talk about road infrastructure. Road infrastructure, it's a major and a key asset for every country in the world. It's 1% per country that invested in the road maintenance and road construction every year, 500 billion investment globally. So that's a key asset. And within road, for 1 kilometer of highways, there is a huge consumption of construction materials. So we talk about 40,000 tons per kilometer for 2x2 highways. 40,000 tons, it's around one big hospital. So the same amount of material in one hospital, or maybe a stadium, is 5 to 6 kilometers of highways. So when you build hundreds of kilometers of highways, there is a huge consumption, and in fact, it's 25% of the whole construction materials getting into this road component. So that's why we look at this specifically, because these materials are taking into consideration really late in the process, and how to get them access to it earlier to mitigate the impact in terms of CO2, take the right decision into that process. You see here that, in fact, the pavement itself is really raw materials, layer on materials, and this design has been selected really early in the process, and that's why that's what we challenge with the BIM processes. Is take this as early as we can and design it as early as we can in the best way. This decision that we take here will impact 60% of the construction cost and 85% of the CO2 emissions for this pavement. So we do that. There is a fragmented value chain, meaning that we have a design part and then an execution part. There's a strong separation, and the public tender is here to separate both worlds. So the information about materials that is carried out by the material suppliers and the contractors can't really transfer and get accessed by the designers themselves. This is creating a gap because of the low digitization of the material suppliers, but also because of this public tender wall about prices, logistics, materials quality, materials CO2 emissions, and that's the gap that is creating around 15% of overcost. But we will see that in different countries and different case of roads, this impact could be really much higher than that. So that's the one that we will talk about today. So how to connect the material knowledge, material information to the designers and to the whole value chain, so we can take better decisions. In fact, the big challenge in designing the road is that you run this assessment with a few assumptions. You know the loading, you know the soil capacity, the climate, and then you select a few designs that will perform adequately in terms of safety. But within this design, there is materials that you don't have access to the information to what is available really locally. So you take these materials, you run the assessment. Performing that design is taking some time. You can't make the effort to run 10, 20 assessments. So there is one or two decisions, usually, as usual, I would say, in terms of design decision. And that's what we also want to improve, is the access of multiple comparison of multiple design. The third step is about optimization of this design, and that's where it's today a bit difficult to really optimize for the planning of the construction, the maintenance cost, and identify the supplying asset. We've prepared just a slide for those who are not from the road. So what's a road pavement and the typical cross-section here. So the pavement is really made to transfer the load from the traffic to the soil in place, and for that you create a structure of multiple layers of materials. And in this example today, we will really focus on the structural design, meaning base course and surface course of the pavement. Then you see that materials are involved in other course, and that would be also taken into consideration later. But for today, let's focus on the structural pavement itself. To perform a pavement design, what you need is the road structure, the different type of layers and the composition of these layers, the type of road, if you are on the structural network or non-structural network. Then the load condition, meaning mainly the traffic condition and the trucks, also the platform classification, so the soil in the area of your project, how it will perform, and a few climate information also around freeze and so, and also the high heat. Based on that, we will see in the demonstration, we have access to a catalog to select a few pavement structure and then perform the analysis to compare these designs. Just a few words about ORIS itself. So ORIS, it's the material intelligence platform. So the idea here is really to connect the material knowledge, the material database, geolocally available with the product, with their performance, their properties, mechanical properties, and so on. Leverage on this database with algorithm, AI, but also the standards approach, material standards and pavement standards, and the pavement structure themselves. And using both, running some assessment on 4 dimensions. The third component is about the security, of course, because there is a transaction of information, so a secured transfer here. And for that, we are working with IBM closely in the team to really secure this flow. But based on the first two, what we are doing is performing the assessment of each pavement option on 4 dimensions. The first one is the construction cost, material, logistic, and placing. And the environmental cost, I would say, carbon footprint emission from the production of the raw materials, transportation, and also the placement on site. We have also a sustainability assessment regarding the effect on the long term. So what's the effect of this design choice on the fuel consumptions of the vehicle, for example, or on the maintenance operation that will be required to have a full life cycle assessment of this road pavement. And finally, the resources itself. So what is available locally, what part of it is recycled, and what can be recycled later. So what we will focus, what ORIS can be used in different stage of the whole process that we've seen. And today what we will focus on is really the material engineering part. So how do we improve and leverage this material knowledge to augment the pavement design processes towards more sustainable roads. So I'll let you continue.
So now ORIS doesn't have any more secrets for you, so we will explain how the workflow with BIM continue. You understand ORIS is a database sourcing material, but you also want to work on your BIM project, and we decide to connect CV3D software to ORIS. So the idea is that you get a design project, and you will feed ORIS with this data. So we will follow this 4-step of workflow, and the first one is to create the design in CV3D. So if we are good, yes. So the first thing is to create the project. I hope you can see where we are. And you will have the road axis. So this road axis between your point A and your point B will be the base for your georeferences project. You will have also to check the altimetry and all the geometrical elements of this project to implement those information into the ORIS element, because you will see it will be possible to have some volumes to be treated after that. So for the moment, you work as usual in creation of your corridor, your axle, and this will be your basic element of work. You will also generate a typical profile. For the moment, you don't know what kind of pavement you want to use, so you get this typical profile with a width, and this is also the first element to feed the rest of the workflow. So you are in the Civil 3D environment, and you will then connect. So the idea was to generate a connector between ORIS and Civil 3D. How this connector will work? Okay. You got at the beginning the little click button, and you connect to the server. After this connection, you remember Renaud explained that you need some input. So you choose your project, you choose the section, because if you are working on 100-kilometer road, perhaps you want to divide it in different homogeneous sections. So you choose it on the right panel, on the left panel, sorry, and you precise some input regarding the length, the width, what kind of unity you will use, in which country you will work, because ORIS is not only working in France. And here, you remember, he said that you need some classic traffic classification, platform element, and structural or not structural network. So when you put this element in the very first stage, you obtain, for the French, from the catalog 98, but if you are in another country, it's other kind of catalog, you obtain all the pavement that could be possible if you cross the traffic and the platform. When you get all these possibilities, you want then be more precise and choose specific element, if you want to be in a rigid pavement or in flexible pavement. So you will select some of them, and you can also be more precise about the wearing course, if you want something specific with a high modulus or thing like that pavement. And after choosing these different specific pavement, you will have the generation of the calcul of cost and carbon. So here, for example, we only choose 4 options. The algorithm behind calculate where to source this kind of pavement, and you get the comparison in blue for the cost and in green for the carbon emission of each kind of layer. So you understand now that you are not only working on the design pavement, but also the impact that you get around your project. And that's why you need at the very first stage the georeferencing of your project with the corridor. And then at the end, you can also export the PDF result to join it to your report or something that you had to provide to your client or you want to archive. Take the rest.
Thank you, Nolwenn. So that's what is happening on the Civil 3D part. So when you create that project in Civil 3D, in fact, you can also access it from ORIS directly and run the assessment in a bit more detailed view. So you can load your project. The video is a bit slow. So you have the whole information at the same level. So you geolocalize your project, you find it here on the map, and you also find all the sourcing capabilities around that specific project. So the quarries, the asphalt plant, concrete plant. This allow us then to take each of these potential sourcing options to run the calculation from this point for a specific layer to the access point of the project. So all these points are real elements, and you can also switch to satellite view to compare and to check all that. So behind all these points, it's a site with a product list, and all the products have some parameters and fulfill some specific standard that can be also accessed from here. So based on this geolocation, we can launch the calculation on the 4 design that has been selected in that case. And each design is recreated into ORIS layer by layer with the right widths to assess the quantity of material that are required. And based on this quantity of material, we recalculate all the dimensions. So the 4 dimensions I talk about, cost and CO2 that we've seen in the plugin on the interface of CV3D, but also within ORIS itself, in this platform, you have access to a bit more detail, a refined detail about all these dimensions. So for environmental impact, it's divided in 3 here. So the A1 to A3 part, production of the raw material, transport and production of the product itself. Then the transportation from the asphalt plant, for example, to the job site, and the placement of site on the site. So for each of these solutions, each of these sources, this is calculated and available here. Same thing for the cost analysis of this solution. And that can be also studied which layer is impacting most all these dimensions to have a refined view and improve the decision process from the engineer or contractors to that stage. And finally, this is closer to what we see within the plugin itself. So the 4 dimension on the same time to be able to compare that. If you take CO2 here, there is 18% reduction between the second pavement and the third pavement for the same road, for example. So these impacts are major, and this can be accessed without the connection to what's available locally. The price impact here in that project is really lower than what we see in the cost in the CO2 analysis. We've performed 2 projects. So quickly, no, that's what I. Nolwenn m'avait dit. Okay, the second example, quickly, just the same. Just to show, the idea here is really to show that if the geolocation is really key to the result that you will access. You can't say the best design in that location is this one, so I can use this one everywhere. It will really depend on the availability of the resources around and on the specification of your pavement, obviously. So here again, it's a different location, different sources, and we run the assessment. Just want to go a bit deeper. So from the satellite view, you see also that the sources here around are the same. And this databases is really the heart of the process here. What we are improving in terms of CO2 analysis that we can see here is that we also implement the use phase analysis. So what's the impact of this surface course, for example, on the fuel consumption of the vehicle over the next 20, 30 years, and also a connection to the evolution of climate condition that is considered here. So if you want a more detailed view, we can talk about that also after. So they have also a classification of your different design, just as a decision support tool to be able to export and share this with the user. But the most important part would be then, once I've selected it, how to resend it to the model, and that's what Nolwenn will talk about. So
you understand that you start your project, as usual, in the BIM part, you use this information to exploit the database from ORIS and to see or directly in your design software or in the dashboard what happened. We said that in this presentation, we were quite focused on the design, but you understand also that there is a maintenance take into account. If you choose the pavement A, B, or C, you know that in 20 years, things will evolve differently. But what we want to do now, and it's not yet ready, but what we want to do now is that thanks to ORIS, you know which option you want to take, and you remember I tell you it's typical profile that we use at the beginning. Now we can use the profile that is compliant with the needs or economical or carbon responsive. And this is where we start then to use another part of the Civil 3D, which is the subassembly composer. Each material got a code. Those codes are connected to the widths and different materials that you selected. You remember we got 4 options. If we say, okay, I take the option 2, there is a width associated. And you can, thanks to this routine, take back this kind of pavement and reuse this specific and not classic cross-section in your project. So here you see that you will add this specific pavement structure, and you can re-export that on your corridor and then obtain in your model the right material with the right property and the right volumes. And the loop is closed. So this is the idea of our next step and how to finally have some continuity between the BIM and the data that you can see after when your model is now ready. You can also open it in a classic viewer or something like that. And everything is referenced with the proper attribute that you selected in ORIS. And I think we are close to the conclusion.
Thank you. So here really the idea was to demonstrate on a specific case how we can initiate the alignment, run the assessment of multiple projects based on the location of the materials and raw materials around in the area of this project, and get back the information within the BIM ecosystem or in the model directly. This slide is really about the fact that if you select 2 different roads in 2 different areas, the results are not the same. The truck distance are totally different and so on. So that's why connecting to what's available locally, it's key. And the idea is if you take it into account as early as you can, you will really impact your CO2 emissions drastically in this assessment, instead of taking this into account really late to monitor what you've done. Thank you, Nolwenn. Thank you for your attention, and yeah, stay here.
Hello. Wait. Thank you for this presentation. Xenia, do you have any questions on the chat?
Hi. No, I do not have any question on the chat. If nobody has questions, I have one myself.
Okay, because we have maybe questions about how to use this this software, ORIS and Civil 3D, and what's the level of training they needed, the engineer, or to use this system? It's difficult to connect or to be really a specialist, or?
If you are already using Civil 3D, it's really easy. The plugin is, we got a discussion of 2 hours and it's okay regarding Civil 3D. Mm-hmm. Now, regarding ORIS.
I think it's quite easy to use for a road engineer to move forward and to run the first pavement and select the pavement and run your assessment. So we have different way to interact with engineers, and we can start also with a consulting period where we really work with them on the first 1, 2, 3 projects, what's needed to really get into, enhance all the leverage that we can reach by using these databases. So that will be, I would say, a case by case, but the plugin one is really
Easy to use.
easy to use, so we can onboard with these processes.
Okay.
If I can add only one thing, the idea is also that the use of ORIS could be not only selected for pavement engineer. If the pavement engineer can talk with the people who are drawing the model, he can, you remember we had to put some input. If you tell your colleague, okay, put that kind of input, regarding the BIM part, he can be quite autonomous. Regarding the analysis of ORIS, it's more about pavement engineer.
Yeah.
Okay. And we have a questions with Xenia about your presentation, because you present it was for a new road, for a new project, and for the maintenance. How does it work?
Yeah, so you can, so currently what we have also integrated the maintenance operation phase with a similar approach, saying that there is a scenario, a basic scenario for this maintenance operation that is integrated in the life cycle analysis. So if you start with the actual roads and enter the maintenance operation as a design, then you will be able to perform the same analysis. And what I maybe forget to mention in terms of difficulty, I think it's quite easy to get on board, but the easiest part is to get access to the results. So once the input are done, you've run some CO2 assessment and CO2 emission calculation. It's instant and it's really easy. I think it's a way to democratize also this approach to monitor the amount of CO2 emitted for the construction of a road with a few clicks. Yeah.
Okay. Thank you. Do we have questions in the? Oh, yes.
I also have a question online afterwards.
Yeah, a slight question is about how do you imagine the role of contractors in the process in selecting pavement materials and including, in fact, their plans, their source of materials in the design and in the calculation?
Yeah, that's a good question. I think as a contractor, you can have multiple approach to this. The first one is, as we've seen here, capacity to identify alternative solution that you can't foresee at the beginning because it's not something that you usually use. And then with this, you have some alternative that can help you to gain the market. And also, I would say more at the execution stage, get closer to the procurement, identify also or visualize easily what's the impact of each suppliers on the CO2 impact and on the cost. Obviously, as you also as a contractor, you integrate your sources into that. You have also the capacity. I mean, I haven't shown, but behind all that, we have all sets of calculations. So you can also use that to identify what your source is, how it's positioned against the rest, and to valorize your material or not, depending on the project, because then it will make sense or not. I think that's different ways.
Okay, Xenia, you have a last question?
Yes, in which countries is ORIS available?
Yeah, so currently, in the consulting mode, so where we accompany the users, it's available in any country, I would say. We'll approach project by project, and in a project by project approach, we are able to deliver the service anywhere. Now to go to more instant capacity, like the one included in Civil 3D, it's currently ready in France, in Germany and Belgium, and we are working to implement into more countries.
Thank you.
And in database, we are covering more than 30,000 sites and more than 13 countries currently, but yeah, yeah, where we are really 100% sure it's this tree one.
Mhm. Okay. Thank you for this presentation. So we will continue with the conference, but inspired by REM with it's online.
Right. Mariana, can we check your audio?
Okay.
Hello.
And I can't
Can you-
hear you. You are?
Can you hear me?
Yes.
Okay, fine.
Yes.
Try to. I share the screen.
Yes,
so-
you have to share your presentation,
Yeah.
and we wait for 5 minutes.
Is it okay now?
No, not yet.
Okay.
Okay.
Long wires from Finland. Do you see the presentation?
Not yet, but in 1 minute, I think.
Yeah, okay. Ninja almost tilted is sharing.
Okay, it's okay. You can start your presentation.
Okay, thank you. Okay, our presentation is inspired by REM Automated Road Design Pilot Project in Finland. And my name is Juha Liukas. I'm working as a leading consultant of information modeling and InfraBIM at Sitowise. It's a consulting company, about 2,000 employees. And Marion can say some words. So Marion Senkvain is from FTIA.
We have a problem maybe with.
Okay. Do you see now the contents?
Yes, it's okay.
Yeah. Okay. So here you see the content of our presentation. First, a little bit introduction, the background of REM and the preliminary study about that. Then the main thing. So what we did in the pilot project, and then finally some conclusions about the project itself, and conclusions from a viewpoint of the standardization. At the InfraBIM Open 2019 event in Tampere, a certain presentation caught our interest. It was Brian Wood's presentation on rapid engineering model. It was part of Smart Motorway program of Highways England. The interest highlights were the goal, automating the design of improvement of existing road network. There, the cost effectiveness of design. Can you make faster and smarter? Then the mixture of 80% automation and 20% human know-how, so-called human-aided computer design. And then digital twin road to enable smarter services and autonomous transport. And then the approach, a little bit different, out of the box thinking. algorithmic parametric design and design rules in machine readable format. And maybe one of the core things, the granulation of information along road alignment. So many questions and ideas rose in our minds. Would it be possible to implement something like that also in Finland? Then I think that Marion would like to say some words now. Or would I, do you have some sound problem with Marion?
Okay.
Okay, I can't hear Marion.
I don't know. So you can speak, huh? We can hear you.
You know, it's the microphone of Marion that doesn't. Marion, try to go on the settings. You have a gear icon.
For us, it's okay. We can see and hear you.
All right, then I'll just continue.
Now, okay, yeah, we can hear Marion as well.
Excellent. So yeah, based on the ideas that Sitowise presented, and also the things that the experts had prepared for this research and development project, FDIA, we got a project proposal from Juha and his colleagues. And well, we really liked the proposal. And after evaluating the preliminary project plan, we had an idea of the benefits this project possibly could bring us. Cost effectiveness through design automation for tasks that could have, for example, have rule-based solution proposal algorithm, and better implementation options through a smart process, providing the possibility of rapid iteration rounds, and also digital process and digital twin of a road network that can be utilized later throughout the life cycle of road network development. And also better risk management through, for example, efficient quantity calculation and environmental risk analysis. That obviously today is a task with a lot of manual labor and at times quite difficult also to communicate.
Okay, now I continue. So the duration of the research and the development project was 6 months, and we used agile methods with workshops and 2-week sprints. And instead of existing road, we chose a new road connection for the review. Here the objective was to investigate and pilot data analytics and automation possibilities for collecting data, then impact assessment and planning of a road project. The first part was a study where we make some more detailed investigation with REM, then look at the possibilities of automation in general at FDIA. And then there is also some update needs in the instruction in planning phase of roads. Then there was a proposal for maturity model of initial data and some benchmarking Norway Road Agency as reference. But then the part two was the main thing, the pilot project itself, a proof of concept project where we utilize a complete project with REM approach. Here is a diagram of the REM process. So there is the inputs, collection and processing data, then analyzing, machine readable rules, evaluation, the assessment of the analysis, then the automation, the actual design, then optimizing design with both automation and manual expert work, and then different outputs, results, documents and visualization. As mentioned, a plan of new road connection was selected for the review. That was a preliminary phase of Road 152 design, a regional reservation plan. It's situated north of the Helsinki airport, and it has been then already completed 2020. And there was a need to develop and transfer connection between the main roads of Uusimaa region and support logistic operations. And in the project there was extensive GIS information affecting the planning decision, and it's included also environmental impact assessment comparing alternatives. And there we should combine the GIS information with BIM and that would bring valuable information and analysis for decision making. And as usual in Finland, the planning was implemented with BIM-based tools. Then the big question, how to choose the right data for the experiment. There was a lot of spatial data. The data selection itself is the first part of the defining criteria. And of course there is specific aspects of the project that has been as a starting point. On the other hand, the challenge should not be too demanding for the pilot project. A good thought-out background is provided by the impact significance assessment method Ampere. That's a result of one EU project. And the goal was to develop a simple set of criteria for the pilot project. And you can see here the main aspects: landscape, land use, nature, and waters and settlement, and then construction ability. The criteria was determined as an expert assessment. There is object sensitivity in 3 categories, as you see an example here, and then the magnitude of impact in distance of 3 categories. And this is the same approach as in REM, that you have 3 steps, 0, 1 and 2, about the influence of the aspect. Of course, there is case by case differences. And this was advanced simplification in the pilot. And here you can see, for example, the national nature reserves areas, the predefined sensitivities, high sensitivity, and then there is the 3-step distances about the disadvantage. Then the analysis tool was carried out as in the R programming environment, and it's an R programming language that used here. Then there you can adjust the different sensitivities, the impacts, and then calculate the total points, the disadvantage points, and also take a download about the results. And here the values in the frame points itself, and here is in the right lower corner the scale of the values. And there is 2 ready alternatives, and we have a curtain that you can then compare these alternatives. Here you can, or the user can then put on different impact areas that we have used in the analysis. And here you can see the frame points, the core issue, the granulation of the data. Here we used 10-meter step in the chainage. Then the geotechnical part, my favorite topic, soil-related cost, the constructability. From the base data, which is geological map, we get soil type and soil group. And then additional data, the depth of soft soil, that means clay, silt, peat, as an estimate of a geotechnical designer. And then slope of terrain from the terrain model, and based on above we get the construction ability class for every square, 10 meters times 10 meter. And but in the frame points we used simplified 3 stages estimate. So 0 points is normal situation or circumstances. 1 is difficult, expensive, and 2 very difficult or more expensive situation. And there you can also change the sensitivity value for that. Then a little bit about data flow in the project. In actual planning project, NovaPoint, ArcGIS, and QGIS softwares were used. Then we collect data in different format to analysis tool in an Excel. And from the Excel, from the analysis tool, we get information again as Excel, but then we used FME and Civil 3D Dynamo to transfer or change the information to land XML, IFC, DWG, and exploit that, visualize it different way in Trimble Connect, Vectorio, Power BI, and so on. as mentioned, in this case we had already two ready alternatives, but we made also some basic special raster path algorithms, but this needs more investigation. Then we make some benchmarking with Trimble Quantum, a short one-day test for that, thanks to Argans Finland and Trimble Norway for that. So in Trimble Quantum you can compare the costs and emission, and it's very powerful tool to find and optimize alignments, but there are a little bit different different point of views in these methods. Also, an initial state for initial state data, a proposal for maturity analysis was made. So the basis is the InfraBIM, Finnish InfraBIM guidelines and FTIA's guidelines. So how to classify and what kind of teams you have in the initial model, and then make a quality assessment from end user point of view. What kind of data you get, the accessibility, coverage, currency, and usability. Then some conclusions about the project itself. I think we get very good understanding of the possibilities. There is big possibilities, but the automation and optimization stage is not really tested because the project was already completed. The automation requires high quality and harmonized initial data, and also it requires quite a lot common attention and time to set the right criteria. And then here Marion maybe say some words.
Yes. So we also learned that this approach can well be used in a wide range of reviews, which can support decision making. And also the next step is to deploy this method at the beginning of a project. And also existing road rail cases would be really valuable to have a closer look at in the close future.
And then conclusion from the standardization point of view, that it's I think standardization is absolutely core issue in the analytics and automation if you really like to use the method effective. So there is a need of standardization of initial data, the criteria, classifications, terms, property sets, and then of course the data transfer. But there is big opportunities of merge open GIS and open BIM information and find a good balance with that. And of course IFC 4.3 that has very great potential. I really expect a lot of the real implementation of different programs with that. But then what I think we had already seen in many presentations that there is no single truth, no single standard. we must merge BIM and GIS information and other data sources and tools and standards in intelligent ways, but hopefully not too many of them. So, merci, kiitos. Thank you for your attention.
Thank you. Thank you for this presentation. And any questions in the room? Or Xenia, do you have questions on your side?
No question on the chat yet.
No. Okay. Well, it was... see, there is a question here.
Hi, thank you very much for your very nice presentation. Quick question on the generative design model. Do you take in account all the connected roads into that model, and do you also take in account the vertical alignment of the road project?
No, in our pilot project, we concentrate in the GIS data, the environmental data, but of course and then in somehow with the geotechnical part we take the vertical alignment also account, because it's dependent. There is some the class or the estimate depends on the height of embankment and so on. But this is very simplified pilot.
Okay, thank you. So thank you very much for this presentation, and have a good day. Bye.
Bye. Thank you.
Yes, so we can continue to the next and to conclude this session with an approach. And it's online too.
Yeah, I hope you can see my screen and that the sound is okay.
Yes, we can hear you, but not your presentation yet.
Okay.
But it takes time
Okay.
for the techniques to show your presentation, I think in 2 or 3 minutes.
Hanna, do you want to take this time to introduce yourself?
Yes, you can.
Yes, yes, I can do so. So my name is Anna Neidenström. I work as a BIM specialist at the Swedish Transport Administration. And there I support our projects with BIM, and also I'm involved in a lot of initiatives regarding R&D projects, and both national and international. I'm also part of Building Smart Infra Room, part of the steering committee. So a lot of things regarding information management and BIM.
Great, looking forward to hearing your presentation then.
Yeah, is it on screen?
Yes, it works.
Yes, perfect. Let's go. With this presentation, I would like to introduce you to a project where we aim to reuse the information models from design and construction phase and to transfer these into maintenance and operation phase. So going from PIM to AIM. Today, there are challenges with model-based information deliveries between PIM and AIM regarding content and form. The project investigates possible solutions for standardized deliveries, long-term storages, and usability of models in maintenance work. So a bit about the Swedish Transport Administration. We're responsible for the long-term infrastructure planning for road traffic, rail traffic, shipping, and aviation, as well as for the construction and operation of state roads and railways. We're a sparsely long populated country, and there's a lot of buildings and assets to plan, build, and maintain. So hopefully this graphics will give you a bit about the size of our mission, and also showing the Swedish Transport Administration in numbers. So the project I would like to present for you, it's the Stockholm bypass, Stockholm Förbifart Stockholm. It's a new route for the European highway E4 past the Swedish capital of Stockholm. This is one of the largest projects run by the Swedish Transport Administration, STA. It connects the southern and northern parts of the Stockholm County. The calculated cost for this project is almost 4 billion euros. And to minimize the impact on sensitive natural and cultural environments, 18 kilometers of the total of 21 kilometers of the road length are built in tunnels. When the link opens for traffic, it will be one of the longest road tunnels in the world. By 2035, we estimate that the Stockholm bypass will be used by approximately 140,000 vehicles per day. The construction of the tunnel, it started in 2016, and the bypass project is one of the first projects where STA decided to implement BIM. Not all disciplines are producing BIM and 3D models, but the main disciplines are to use information models instead of drawings. Models have been used all the way from design and tender phase, through construction, and now to the operation phase. In summer 2022, the first phase of the project will be delivered and the handover is initiated, so it's ongoing. So that's what we're working with. It's not easy to introduce new workflows, and we do have a lot of challenges. As an owner and operator, we are managing both the past and the future. For a long time still, we have to be able to manage both the old projects and the new, and to find solutions that can merge these two worlds to make use of all opportunities. The projects we complete today, we started to plan like 30 years ago, and the tunnels we build will stand for more than over 100 years. This means that the changes we introduce today will take time before they are fully implemented. In the old projects, we have fragmented data stored in old repositories, and PDF was the current format for both the final delivery and for storage. For new projects like the Bypass Stockholm, we include more data and change our processes. We have to include multiple formats to ensure the full story and to enable that the information can be used for different purposes. We do work hard to supplement the delivery with formats that can provide data that we can actually use. For the Bypass project, we are introducing new archive formats to enable the transition from drawings to models. IFC is to become the new format for long-term preservation. Because we don't have open standards available today, we have a variety of formats to manage in our portfolios. When the design for the Bypass project started, it was decided that it was to be based on DWGs and DGNs to be used as the exchange formats. Different platforms and software is used for the design, and a variety of formats are delivered as additional data. Depending on the discipline doing the design, we have to optimize the delivery and choose the formats that best fit our needs. Usually that is not only one format, but multiple and files that must be created. This put a lot of stress to our projects, and every project must be planned and adapted separately to make sure that we can make use of the data created. Information is trapped in proprietary formats and is mainly used for visual purpose and coordination. This is usually the base level of BIM in our products today, and we are struggling to become more independent of the software that is used in the different projects. Open standards are not yet fully implemented, and we lack common formats. Common formats that could make exchange of information easier and also more accessible. Having access to open standards and the implementation of IFC will make life easier. And for the bypass project, we are now trying to transfer data from proprietary formats to IFC 4.3. When working with the data created in the bypass project, we have learned a lot about what it takes to create a platform for a digital facility. We have developed use cases for different scenarios that we are now able to test live, and we are learning more about the change required to transform from managing drawings to instead require information and models. A common structure must be implemented with clear classification and also identification. Different systems must be able to understand the data, and the integration between systems must be defined to optimize the communication. The information is what matters, and how you preserve it between different phases and handovers. Information and data, it's an asset like all other assets that must be managed in a structured manner. The goal for us is to create a platform that will allow us to manage a proper digital facility, to standardize the handover from different phases so that we can actually utilize the information and visualize our facilities. The bypass project is pushing the boundaries for our transformation and has enabled us to develop methods for transferring the PIM to an AIM. We're beginning to learn how we can use the models for operation and maintenance to become more data-driven and to improve efficiency. From the start of the design, models have been used for different purposes like clash detection and visualization. Our different contractors have also used the models for construction and simulation and machine guidance and such things. Changes in construction that impacts the execution are communicated back to the design model, and the PIM is kept up to date. The challenge we see for the bypass project is to preserve the data, making sure that the correct data is transferred from the PIM to AIM. Not all data is required in the AIM, and it will therefore stay in the PIM. Part of the data is very specific to the operations phase and will only be added to the AIM. This must be defined, and requirements must be added that make sure you get the correct data added in the correct format and at the correct time. We want to be able to link information to objects, and to do so in a way that allows the information to be used for different purposes, at different times and by different actors. Because we did not have access to open standards for all disciplines, all the different formats must be managed and different methods must be used for different files. This is something that we see will change and improve when we introduce the IFC format across all projects. A common language will definitely make the transition from PIM to AIM easier. The quality of the data will increase, and managing the data will be so much easier. A very nice lesson we learned when working with the bypass project is that the use of GIS can simplify the exchange of data, and that we can actually use a lot of our current systems for managing data through different phases. The combination of BIM and GIS has a lot of potential and will help us to overcome challenging challenges sorry, when managing data and workflows that include different stakeholders and different phases. We already have multiple systems today where we add metadata and specific data for all our components. The system vary depending on the phase we're working with. An integration has now been built between these two systems, allowing us to synchronize and to keep the data up to date in both the PIM and the AIM simultaneously. Our current databases can be included in the new workflows to enrich models and to enable us to transfer data from construction to maintenance using GIS. This allows us to build the data and get access to data required for different measures depending on the task we're working with and the specific needs that we have. When something changes, it's updated in all our systems, making sure we always have the latest data available. BIM, it requires a change in mindset and also to dispute current ways of working. We are very familiar with how to set requirements for the physical facility, but to set requirements for the digital facility is new and will require a lot of work and a lot of questioning. What do we actually need to maintain both the physical and the digital facility? We build our facilities for society and for our customers, and they are not really interested in the digital facility. They care mainly for the physical building. But for us to be able to provide a fully operational facility, we need to improve our digital capabilities. We need to change from our analogous approach to become more data-driven. To do that, we also have to change our requirements to include the requirements for the digital facility. And we have started to go through our current requirements and to improve them to make them more machine readable. It's definitely a challenge, and having access to a standardized platform and open standards will make this work easier. So, we see a lot of potential using the 3D models and integrating data in maintenance and the operation phase. And we see almost the same use cases in maintenance as we do for design and construction. For complex facilities, we will be able to analyze and to test solutions virtually before executing. The 3D models provides a much better overview of the project, an overview that is many times hard to get from the drawings. Another use case that we see a lot of potential in is the ability to automate inspections, to be able to scan and map damages and to automate detection and recognition of damages on our facilities. In our daily work, the models can be used for detailed measuring and that are more accurate compared to the drawings. They will improve the design review and also minimize errors. The models will allow us to reuse more data. For an example, the scanning data that can be integrated for damage inspections, etc. It's also a powerful tool for collaboration and coordination, adding different disciplines to enable a proper review of different techniques represented. To summarize, we see the use of models in asset management as a very important tool to reduce loss of information from the construction phase to the operation and maintenance phase. Today, the design of facilities is increasingly more based on BIM. Through the digital design, a large amount of information capital is created and accumulated in the model. By not using the models and incorporating them in the maintenance and management of the facility, information created during the design will be neglected and we risk huge losses of information. We see an increased interest in starting to provide information that can be obtained from new and innovative digital methods. For example, image-based inspections, damage mapping, laser scanning, machine learning for damage detection, etc. To increase automation, we must become more data-driven. Having access to reliable data will allow us to reuse data and to introduce new workflows. The models will enable us to collect different sources of information to fully visualize our facilities. It will become the main hub for decision-making and improve efficiency and the quality of our services. With structured data, we can better understand our facilities. Drawings contain limited amount of data, and the data is very hard to find and manage. With access to databases and structured data, it will be easier to manage our facilities and to keep track of all the components included. With maps, for example, we can visualize areas and color code them based on the condition to create better overviews, making it easier to navigate through the different layers of data. The Bypass project is showing us the direction and the opportunities. And for our future projects, we have collected valuable insights that will help us to improve the setup. We must make the transition easier, and we must continue the implementation of BIM and open standards. We are moving forward, and the communication in our project is improving, but we still have challenges. There is great variation in the quality of the data that is delivered. The information is usually presented through the layer name and in a 2D model. The outcome is very much depending on the organization involved in specific projects. And to overcome this and to become more digitized, we want to move from requiring drawings and instead work with models and model-based data. We need to have the correct information included in the model, and it needs to be complete. Instead of documents, data should be stored and presented in databases. No more PDFs. And finally, instead of proprietary formats, open standards should be used. No more trapped information, but data that can be reused and refined. So what do we see for the future then? Well, looking 10 years ahead, we hope that we are fully digitized, connecting the entire life cycle, and that we have managed to establish a fully digital representation for our most critical facilities. We have a seamless transition in place that ensures data to be transferred all the way from the construction phase to maintenance and operations. Documents are completely replaced by models and databases to ensure a proper data flow and minimize the data losses. The condition of the facility is mainly defined by automated processes using laser scanning and artificial intelligence for inspections. And more automated workflows are implemented. For example, decision documents for prioritizing measures are generated automatically based on algorithms and parametric conditions. The Bypass project has taught us the value of data, and we are adopting new workflows that will allow us to make use of all information we produce. We have started to change our requirements to make sure we will have access to the right information at the right time for the right person and for the right purpose. We are moving step by step, and through our projects, we collect new knowledge. The change in mindset is initiated, and we do see the value in keeping the digital facility up to date and to incorporate that in our daily work. Hopefully in 10 years, or preferably less, we can summarize and look back on a very interesting journey. Thank you.
Thank you very much, Anna, for this presentation. It was really clear, and I think it's I'm really impressed for this approach of the Swedish Transport Administration. I think it's the right way to use the data and to manage the data in our project. Do you have questions in the room? Yes, we have a question.
Thank you for your presentation. And one question: does Swedish Transport Administration already has the employer's information requirement EIR document, or is it similar for roads and the railways? And is it publicly accessible? Thank you.
So we have kind of an EIR, but it's documented in multiple documents. So we have something that we call TDocs. So these are summarizing our requirements and specifying the requirements that we have for information delivery. It's not complete, and we need to improve them. And definitely we need to think about the digital facility and what is required for that representation, and not only the physical facility. So I think that's where the main work is still to be completed. It's publicly available, so most of the TDocs you can download them from our webpage. So all the suppliers have access to the requirements. And it's mainly, I think we have more requirements on railway than we do on a road product, but the baseline is pretty much the same.
Okay, thank you. Xenia, do you have any questions on the chat?
Not from the chat.
Not?
I have not from the chat. I have one myself as usual. If nobody has other questions.
Okay. So, what's your question? Do you have a question?
Okay. Well, more than a question, it's actually a consideration. And it comes basically from a couple of things. The first one is you, Anna, talking about the relationship between this physical world and the virtual world, right? The digital world. And the other consideration is about the requirements and the employer information requirements, or exchange information requirements, as they're called now. Now, the consideration comes from the requirements engineering approach. And so far, at least here in Italy, I'm Italian, right? We have actually a document for the, let's say, physical and functional requirements, and literally another document for the information requirements. I think that as long as we keep this approach to two different requirements that do not see the system as a real system made of the physical and the virtual things, we will not be able to join these two different sides of the twin, right? The physical and the virtual. So the question is, do you think that requirements engineering approach coming, let's say, from the systems engineering world might be useful to reaching this combination between the virtual and the physical souls of our infrastructure?
I think what we learn in the bypass project is that you need to think about where you put the data, where should the information be, and where is the best place for different kinds of information. So I think the combination is probably a good thing. So they will be combined. So some data will be shared between the physical facility and the digital facility. It's a common data. But we need to see for the digital facility where it's best to place it. Where should it be placed, and where should you find the different data sets? So I think that is a huge challenge, to actually find the best container for the data.
Thank you.
Okay.
Yeah, I just want to add, it's not, I think sometimes we are so eager to put everything in the BIM model, and perhaps it's not always the best thing to do that. So that's the considerations we need to do in the, when we maintain and look on the data that we require for maintenance. Where should it be placed and stored?
Clear, thanks.
Yeah.
Okay, thank you, Anna. I think it's clear for us, and we can conclude and have a good day. And thank you for this presentation.
Thank you.
Thank you. Bye.
Bye, everybody. Thanks.
Thanks, Xenia. Thank you too. C'est fini? It's closed? Okay.